We've got a couple of pictures of volcanoes here, but that's not really the important thing. The important thing is, as I was talking to you yesterday, mostly, I don't know, I was talking to myself mostly because I couldn't see all of you. It occurred to me that some of the little boxes we've been checking off, shield volcanoes could be chosen in some other places. I think I told you that maybe it was East African Rift Zone, where Africa's breaking apart. There could be some shield volcanoes there. And then I started thinking, well, maybe there could be some in other places. But I've been generally telling you that at divergent boundaries, there aren't really any volcanoes. There's just, with the mid-ocean ridge, there's a long ridge, there's a crack, there's ocean floor being created, and that's true, but every once in a while you do get a little shield volcano there. So I wanted to show you that. Let me put this here. So composite cone volcanoes, the two kinds of volcanoes I've talked about so far, composite cone and shield cone. Which one of these is a composite cone? One's a shield, one's a composite. Anybody know? Is it the top or the bottom? Which one? A composite of anything is multiple things put together. So a composite cone is the kind that has different layers of light and dark material. So it's got some of the mafic runny stuff that comes out, and then there's an explosion of felsic ash that settles down, so you get the light stuff, and then the dark stuff, and then the light stuff, then the dark stuff. So which one of those is this? The top one or the bottom one? The key is the steepness. In order for a volcano to be steep like the top one, it's got to have some of it. There's one type of magma or one type of lava that allows it to be steep. The other kind just won't ever pile up. It just flattens out. So this top one has that. Anybody? Is that a composite or is that a shield? It's a composite. So the top one's a composite, and I think that's Mount Rainier from Washington State. Mount Rainier is it's a really cool mountain. I used to live in Washington State, and I've been hiking up Mount Rainier. In some ways, I don't really like Mount Rainier because you can't take dogs, and we always like to take our dogs on hikes. And if you want to backpack around Mount Rainier, a lot of people do it, but you know how when you take your dog out, you've got to take a little poop bag. So when you go hiking around Mount Rainier, you've got to take a poop bag for yourself. And a lot of people don't want to go hiking there because of that. At least that was the rule back when we lived there. You couldn't bury, anyway, I'll move on to a different topic. So that's Mount Rainier, and it's a composite cone volcano. And there's a lot of concern that these glaciers that are up on top, if it erupts, those glaciers will just suddenly melt. And they'll all start running down the hill in these big mudslides called lahars. And they'll bury people in Puyallup, Washington, and all the other cities that are near Mount Rainier. So it could be really bad. There are a lot of big volcanoes like that. That's kind of what Mount St. Helens used to look like before it erupted, and that was really destructive. There's Mount Baker up a little bit to the north. And so where do they form? I've got a few links here. That one forms in Washington State, but they form anywhere where one plate dives beneath another plate. So in Washington, it's the Juan de Fuca plate going under I think the North American plate and melting down here and rising up and making a volcano. Let's see where these links go. So the Andes Mountains, those are some I told you about. This is just a Google search of Andes stratovolcanoes. That's another name for composite cone volcano. These are the Japanese composite volcanoes. So it happens in Japan. One ocean plate dives beneath another one. These, let's see where this takes us. These are in Washington. So that's the picture of Mount Rainier I just showed you. I don't know what these other ones are. Oregon, they have some of them too. Mount Hood is a volcano. As I've already mentioned, Mount Baker. Mount Rainier is probably the most famous one. It's really cool looking if you go to Seattle. And then Alaska. There are a bunch of them in Alaska too. The Aleutian Islands is this little, well, I guess it's an arm of Alaska that curves off like this. And one plate dives beneath another plate there and creates those. So there are a bunch of them there. Now shield volcanoes, number one, I think will take us to what I've told you about. So Hawaii, this picture shows the shield volcano. They're not really steep, they're just made of the runny kind of lava, so they flatten out. And the eruptions of those, you can see, are just lava flows. If you touch that, that'd be really bad, you get burned, but you don't, if you're a mile away, you're fine. The other kinds of eruptions are the dangerous ones. Let's see. Here's another place you can get shield volcanoes. So this is the East African Rift Zone. I just Googled East African Rift shield volcanoes. And there are some. Here's the rift that's opening up. And this is a volcano, but over time, as that rift separates, the volcano is going to just get destroyed and more stuff's going to come up in between. So mostly what's happening here is we're getting new ocean crust that's created. That's the main thing. But on a test, if you wanted to say there are shield cone volcanoes, there could be. Anytime you have mafic lava, you could get a shield cone volcano. And one other place where they happen is Iceland. So this kind of looks like Hawaii again, but it's actually Iceland. Iceland is where the mid-Atlantic ridge is splitting apart, and for some reason in Iceland it's just moving slowly enough that all the stuff coming up can pile up and actually create some volcanoes. That's Africa again. So other kinds of volcanoes, they're not just two, and I don't want to spend much time on them, but here's a list of some other kinds of volcanoes that if you want to know more about, you can. Let me go down. So they mentioned cinder cone, composite cone, that's the one I've just been talking about, shield, lava dome, and that's all they list. So a cinder cone would be kind of like just the felsic stuff. If you just had the gooey magma coming up, and when it erupts in really chunky, gooey bits, they're really steep. So sometimes you actually find those next to or inside composite cone volcanoes. Lava domes, this is pretty much like a shield volcano that's just been dormant for a while. So, or maybe it's not even that. It's just anytime you have a dormant volcano that gets plugged up, and you build up pressure and it starts to go and push out like that, like a dome. So it's not really its own kind of volcano, I don't think. I'll never test you over those. I just wanted you to know there are some other ones. All right, homework. So if you haven't already checked your homework, get it out so we can check it. At some point you're going to have some questions like this on a test or a quiz or both. And so in this unit, I want you to be able to do two things. I want you to know what's happening at different kinds of plate boundaries, but I also want you to know why it's happening. And I would say the why is more important than exactly what's happening. So here, these are my answers to the assignment. I don't know if you watched the video and you did it along with me. You've already heard me go through this, but it probably wouldn't hurt to do it again. So the first thing you're supposed to do is draw a, didn't mean to do that. Draw an ocean, continent, convergent plate boundary. Except I called it a continent, ocean, convergent plate boundary, and there's really no difference. It doesn't matter which one you call it. It's the same thing. Grr. With my split screen, if I push my picture over here too far, it starts to go over there. All right, so this is what it should look like. You don't need all this over here. I kind of got off track and I drew more than I needed to. So you should have a dark plate because ocean crust is dark, and you should have an ocean over it. If you're drawing these, make sure you put water in your picture if you're drawing an ocean. And then a continental plate, which is lighter in color, it's felsic. And your ocean plate should really have some sediment on top of it. And the sediment, well, first of all, they should be moving together toward one another. And the sediment should get thicker in the direction that it's moving. And that's because just like old things have a lot of dust on top of them, the oldest part of the ocean floor is going to have the most sediment. And this part of the ocean floor is the oldest, so the sediment's really thick there. This part is the youngest. And the way I can tell this is the oldest and this is the youngest is because it moves this way. And I know somewhere way back here, if I retrace its steps, that's where we've got some kind of a divergent boundary creating new ocean crust and then pushing it away. So you need to remember that ocean crust, or any crust, always gets older in the direction that it's moving. It's born over here, and then it moves over there. It's like it's on this long treadmill, and then it just gets recycled down there. So another thing, you need a volcano, and the volcano should be the steep kind because it's got the light stuff in it, but it should have alternating layers of light and dark because the lava that forms it is coming from this melting ocean crust. And the ocean crust has two kinds of components. It's got the mafic crust, and then it's got the felsic sediment that's on top. And that sediment's pretty important. That if it weren't for that sediment, this wouldn't be a steep volcano, and we wouldn't have really big explosive eruptions very much here. Even if this plate were an ocean plate, there's enough of that sediment there to cause this volcano to be steep and to be violent sometimes. All right. So, oh, and the one other thing, the currents should move together since this is convergent, and you should have a sinking current there, and they should cycle around like that. So for the questions, one place should be higher than the other. Which one? Why? Well, continents are higher than ocean. That's why they're continents. There are certain places on the earth that are higher, certain places that are lower, and the lower ones get covered up with water first. As the climate heats up and the water in the oceans expands, it's going to start covering up more and more and more of our crust. And as glaciers melt and drip into the ocean, that's going to cover more and more and more crust. But the first thing to get covered up is this ocean crust because it sits lower. But why does it sit lower? Because it's more dense. So this is like a raft sitting on the mantle. This is like another raft. This raft is made out of air and styrofoam and stuff, keeps it floating high. This raft is made out of soggy wood that just barely floats and sits down really low. So I think I answered that way more thoroughly than I answered it here. When we draw this sort of diagram, how do we know which plate will dive? Well, first off, sometimes neither one dives. And in order for a plate to dive, it's got to be at least as dense as the mantle. You can't get yourself to dive in a lake unless you're at least as dense as water or you're paddling really hard. So this kind of crust is never going to dive. So if you have the less dense kind and the more dense kind, the more dense one is going to dive. If you have two ocean plates, how do you know which one of those is going to dive? You wouldn't just from a picture. It would be whichever ocean plate is the denser one, and the denser ocean plate would be the colder one, and the colder one would be the older one. So in the case of two ocean plates hitting one another, if this one's older than this one, it's going to have more time to cool down, so it'll probably sink. But I don't think I'll ask you that on a test, but people sometimes want to know. How do you know then? Why does one dive? Why is it this one and not the other one? What causes currents to move in the mantle, or what causes the plates to move? It's currents in the mantle. So this plate would not move if there weren't a current there. What causes the rising and sinking currents in this area? Well, the warm parts, which there really aren't any in this area, and there really isn't any rising in this area, but those are where stuff rises, and the cooler places are where stuff sinks because it's more dense. So this is a cool, dense place that causes the sinking, and you didn't have to draw this, but if you did, this would be a warmer place where there's rising. And then these sideways currents, the next one, what causes those? That's momentum. So once this stuff sinks to the bottom of the mantle, it's not just going to stop. It's an object in motion, and it's going to stay in motion. And there's sort of a boundary here, so its momentum carries it around like this. If you remember me blowing in the pepper dish, I can just blow like this and stop, and that pepper will keep on going around like this for quite a while because it has momentum. So these sideways currents are because of momentum. You should have a volcano, describe the shape, explain why it has that shape. So remember, when you're doing this, you're not starting with the diagram. You're starting with that. So you would need to be able to answer this question, not based on the picture that I have here, but based on what's in your head and you creating your own picture. So your answer is, this is a steep volcano, and the reason it's steep is because it has some of the gooey felsic lava in it. And that felsic lava comes from the ocean, the seafloor sediment that melts. So it's this stuff. So it's steep because it has some felsic material, which is gooey when molten, so it piles up steeply. If it doesn't have that, it's just the runny stuff, it's never going to be steep. Number 7, describe the eruptions, gentle or explosive. Well, they can be gentle, or they can be explosive, and it's because we've got mafic stuff and felsic stuff in it. So it's got this kind of stuff that's dark and runny and can ooze out when it gets up here, and then it's got this kind of stuff that's light and gooey and plugs up and builds up pressure and causes explosions. So you can have both kinds. And that's why we have these alternating layers from both kinds of eruptions in the past. Describe the lava. I feel like I've just done that. Yeah, I just did that. Describe the lava that's found here. They're both kinds. And I explained where they came from. The felsic is from the seafloor sediment, the mafic from the melting plate. And I guess on the way up, as this stuff burns its way through this continental plate, it could pick up some of it too. So you could get some more felsic stuff from that. What kinds of earthquakes happen here? Are they shallow? Are they deep? Are they both? And the answer is they are both. So as this dives, you can do some shaking can happen right here. That would create a shallow quake, and then down here this would be an intermediate one, and then down in this area that would be, those are the deep focus earthquakes. Those aren't necessarily stronger or more damaging, they're just deep. Sometimes it would be more dangerous and damaging if the earthquake is closer to the people who live above it. Where's the seafloor the thickest? I already explained this. It gets thicker in the direction that the plates move, and that's because the plates get older in that direction. So the oldest stuff collects the most dust. And finally, how are density and temperature related to one another in the Earth's mantle? I've already talked about this, but high density is related to low temperature. So wherever it's cool in the mantle, you have higher density. And I didn't feel like I had space to write the opposite, but the opposite's true. Wherever you have higher temperature, you're going to have lower density. And examples of that would be right here. This is high density. This is because there's lower temperature here because it's cooler. Over here, there's low density, that's why it's rising, and that's because there's higher temperature over there. So temperature and density are what we call, well, sort of inversely proportional. If temperature goes up, density goes down. Temperature goes down, density goes up, usually. And that's it. So one thing I feel kind of bad about that you're going to love is I feel like I should quiz you over this right now. But, or at least tomorrow, but I don't really feel like we have time for that. So after break, we're going to have to go back to revisiting this because it's important. All right. Soli and Quinn. Quinn, you're at home today. Good morning, Quinn. Quinn, are you feeling okay? Quinn?
Yeah, I just had a sore throat and stuffy nose. I guess I just can't go.
Yeah, good. Yeah, it's a good idea. It's good that you stayed there. Quinn, don't forget to, there's this guy, his name is, I think, Will Rigliciano. He does attendance for the school. He's the one who sends you do they still send you emails that you can verify that you took part? Okay. You need to let him know that you're attending class today remotely, even though normally you're here, because he might not send you one of those things otherwise. And I'm supposed to mark you absent. So I'm going to mark you absent, but contact the attendance people.
Okay.
All right. So this, I kind of want to do a couple of things. I guess I'll do it all. I feel like I've talked to you, and I want to take a little break and do the quiz. But I also don't want to leave these people at home hanging. So I'm just going to barge on through and do the next thing. So in just a few minutes, I'm going to give you this. This is tomorrow's quiz. There is going to be a quiz, and it's not going to be so bad. What you're going to have to do is look at a map like this and identify what kinds of plate boundaries these letters represent, and then tell where in the world do we have one of these. For example, the Mid-Atlantic Ridge, that's a real thing in the world. Which one of these letters is representing something like the Mid-Atlantic Ridge? But before I do that, I want to do one last review of all these plate boundaries. I tried to make what I think is a better slideshow last night. So I'll see if you think it's useful. Maybe you won't, but we present it. Hey. All right, so going through all the different kinds of plate boundaries. There's ocean continent convergent. And this is the example I gave you before. If you look at this picture, the South American plate and the Nazca plate are moving at one another. Guess which one's going to dive? You should know this. The Nazca plate, because it's an ocean plate. And here's some picture I found on the internet showing what that looks like. It's not great, but there's South America. There's the ocean crust. It's going underneath. It's melting. And then there's the trench here, the Peru-Chile Trench. And here's what some of the volcanoes look like. The volcanoes that are forming here would be composite volcanoes, or the steep kind. And those are alpacas because, oh, Jace, what are we going to do? Why don't you just, go ahead and sit behind Anna today. And if this thing erupts, this is what it looks like. Sometimes. So this is one of the explosive eruptions of the composite cone. This would be the felsic kind. There would be just some gentle ones, but this is the more exciting kind. All right, continent convergent. Himalayan mountains, including Mount Everest. So that last one is the Andes Mountains in South America. That's the example I gave you, but there are other examples. So here you can see in this picture, India used to be, 70 million years ago, it used to be down in the Indian Ocean. 50 million years ago, it was here. Today, it's right over here. So it's really slowly been moving. And let me show you something. So I think maybe I told you this. I dropped an air conditioner on my fingernail right at the beginning of school. And that black was way back here at the back of the nail bed, and now it's there. So since the beginning of school, you can see how far my fingernail has gone. That's about how fast the plates of the Earth move. So the idea of India slamming into Asia, it's not like bumper cars. I mean, bumper cars are unsatisfactorily slow, in my opinion. I always want to go faster. I try to get my car to speed up. But they're still way faster than the plates. So if you just remember, the plates are moving about as fast as fingernails grow. That... I don't want to go back to the beginning. Will it start from here? Good. That gives you some idea of how fast they're moving. So India's crashing into the Eurasian plate. And both of those are continental crust, so neither one can dive. So it looks like this. They just kind of smash together right there, and then we get the Himalayas, and Mount Everest is one of those. So example of this is the Himalayas. And later on when we talk about weather, one of the rainiest places in the world is right along here, because warm, moist air comes off the Indian Ocean during the monsoons, and then as it climbs over these mountains, the pressure changes and the temperature changes, and it cools off, and they can get thousands of inches of rain in, I'm trying to remember, I think 1,000 inches of rain in a year is the record, somewhere around there. Cherrapunji, India used to have the record for that. Okay, it's not an alpaca. Alpacas live in the Andes. This is an animal that lives in the Himalayas. What is it? The title, what's that? too big to be a mountain goat. This is the pack animal that the Sherpas use to, what's that? It's a yak, yes, so it's a yak. You see a yak, you know you're in the Himalayas. All right, now we're at the mid-ocean ridge. So this would be ocean-ocean divergent, and you can see down there, it's not just two plates going apart. Or up around Iceland, it's the North American plate and the Eurasian plate, and then down in South America, it's the South American plate and African plate. But it's this whole thing is the mid-Atlantic ridge, and kind of looks like an alligator half buried under the ocean. This is somebody's representation of a relief map of the ocean floor. So it's a long ridge. You don't really see individual volcanoes. That's why I haven't stressed that there are a bunch of volcanoes there. Although the whole thing is kind of a volcano where mafic material flows out. It's just showing another view of it. And it shows how you can have the mid-ocean ridge here and here, but if it's a jagged part, you can also get a transform boundary right on along with that. This is Iceland. And I think Mr. Rome went to Iceland. You can go swimming between the two plates here. And I think I've got a picture, yeah, people swimming between. I don't know whether this is pointing south or pointing north, but one side is North America, the North American plate, and the other side is I see Eurasian plate, I think it is. All right, it's just another picture of here's a good side view of it where I always draw it like two canoes facing off. It sort of looks like that. They don't really show the sediment so much here. And here's an eruption. Now, does that look gentle? Probably not. But if you compare it to the scale of a really, really explosive one, this is gentle. This is like relatively watery stuff squirting out of the ground, splashing down, and then flowing. Mount St. Helens, all the felsic eruptions, those just explode miles and miles into the air and vaporize anybody within miles of them. This is gentle. All right, this is Japan, ocean convergent. And I was going to say which plate is doing what here, but you can see there are all these weird plates. The Okhotsk plate, the Amur plate, the Yangtze plate, the Pacific. So just know that the Pacific plate is going underneath a bunch of other stuff. And these teeth right here, they're pointing in the direction it's diving. So ocean convergent is Japan. And here's a side view of it. This would be like the Japan Trench over here. And the subducting ocean lithosphere, that's the ocean crust going underneath, then melting and rising up. These would be the Japanese islands, and then this would be the Sea of Japan. This would be the mainland over there. There's another picture of it. I like this because it's got these blue dots, yellow dots, red dots. And the key down here says shallow, intermediate. It's covered up, but the other one says deep. Those are epicenters of earthquakes. So I've been talking about shallow earthquakes and deep earthquakes. This is just showing that I'm not the only person who talks about that. And that's evidence for subduction. I don't know if you can see it, but on the map over here, bottom left, in a map view, they have all these deep earthquakes that happen here. And then they have all these medium ones that happen here and all the blue ones that happen here. And they thought, we've got deep ones here, intermediate ones here, shallow ones here. Maybe that means something is diving like this. So as it goes this way, it's getting deeper. So that's actually evidence that subduction really happens. And there's a picture of the most famous Japanese composite cone volcano. And this is the eruption that killed the people in the video we're going to be watching. We might start it today, we might start it next class. The Maurice and Katia Kraft died. This was Mount Unzen erupting. Ocean hotspot. So ocean hotspot is like Hawaii, and the Pacific plate, which is this whole plate, is moving in the way that the arrow's pointing. And there's this mantle plume that stays in one place. So as the plate moves over it, different volcanoes pop up, and as the volcanoes move this way with the plate, they cool off because they leave the hot spot and they get worn down. So this shows ages of the volcanoes. This is 0.7 million years old. Maui is 1 million years old. Molokai is 1.3 to 1.8. Does anybody know what the next one is? I think that's Oahu. is 2.2 to 3.3 million years old. They just get older and older that way. Oh, here we go. Now we can, this is the same thing from a side view. There's the Big Island, then Maui, then Molokai, then Oahu, then Kauai, and Niihau. Has anybody ever been to Hawaii? I went there on my honeymoon, and we went to Kauai and we went to Maui. We never went to the island of Hawaii, so we went to one of the oldest ones and then the second oldest one. And there's what a Hawaiian volcano looks like, because it's made of the runny stuff that doesn't pile up. That's the big one on the Big Island. And this is an eruption in Hawaii, pretty gentle. All right, I think we got two more. Continent divergent. This is Africa. Africa is splitting apart. This is showing, it's kind of messy. It's not like there's a nice crack forming. It's a bunch of different cracks. I tried to zoom in to it on Google Earth and I couldn't really find much. This is the whole sequence. Today it's kind of like, it says stage 2, formation of a rift valley. East African Rift Valley is at this stage right now. So before it would have started heating up and started to crack. Now it's starting to separate. It's going to keep separating, an ocean's going to form, and eventually it's going to look like the Mid-Atlantic Ridge. And there's some of the mafic stuff coming up in the middle. And here's crack forming as it's breaking apart. And finally, continent transform. This is the San Andreas Fault. And at first I looked at this and I thought, what's the red? And it says Rock X, 25 million years. Does anybody know why they would show us Rock X? What's the point? How would this have looked different 25 million years ago? Elijah? Yeah, they're the same rock. So this red and this red, 25 million years ago, they were all one piece. But because the North American plate's been moving, now you can go somewhere a little bit north of Los Angeles and you can find half of it. And then you can go somewhere a little south of San Francisco and you can find the other half. So in another 25 million years, this is going to be way over here. This is going to be way down here. And some of this is going to start going out into the ocean. So here's another view of it. And a view from above. I think that might be it. And then there's, of course, a road where the San Andreas Fault goes right across. All right, so I'm going to give you this little practice quiz. And if you want to keep this, if you do, I want you to take it like a real quiz, put it on my desk. I'll score it. If you like your score, you can keep it, and you don't have to take this quiz tomorrow. And I think some of you can actually do well on this. So if you can't, then you can study tonight and you can try it again tomorrow. Lost my mouse. Let's see. People at home, if you'd like to try it, there it is for you. I'm going to mute this. So Soli and Quinn and Tommy, if you promise you'll do all your own work, and you do this and you send me a picture of it, I'll grade it, and if it's good, you can keep it. So the first part, you're going to need to know based on the dark and light. This is really a couple of quizzes at one. The dark and the light tells you which is ocean and which is continent. And I guess I'll give you that. So the dark plates, what are they? Are they ocean or are they continent? Anybody? Ocean. So the dark plates are ocean. I'm not going to tell you what the light plates are. You can figure that out in the process of elimination. And there's only one answer for each of these. Don't forget to put your name at the top, even though it doesn't really say name anywhere. Oh, you know what? I guess I'll keep on Keep on videoing. This will be like one of those videos of somebody's fireplace, except worse. Oh, the people at home, as soon as you're done with this, you can go if you want, but you may want to stay and see the answers. I'm going to share the answers in a little while. Just try it. Just give it a try. Try both parts. Just set it right there. All right, Reagan? All right, here, you need one of these. And when you're done, you can just hand it to me, and I'll grade it really quickly. Or actually, okay. Thank you. Okay. If any of you, I haven't recorded any of these, if you like your score, just give it to me before you leave. We don't need to do this. That's all right. This is just, I don't know, still good practice. So far, we've had quite a few 12s out of 14, which is good. Those are the best. Nobody's done better than 12 now. Don't kill yourself over this. Just try to wrap it up pretty soon and end in whatever you have. Or if you'd rather just keep it and you don't want me to grade it, that's fine. But if you think you might do well, might as well have me grade it. And you could always have me keep your score, and then if you do it again tomorrow and do better, I'll keep that score. Either turn them in or hold on to them. Anybody have any last ones you want to submit? All right, so people at home, you probably all left, but I'm going to go over the answers now. Just get my answer key from the, actually, I'll fill them out one by one. The first part, as I was expecting, most people did pretty well. I'm going to make a little key up here. The dark stuff, that's ocean. And the light stuff, that's continent. So aside from that, all you really need to know is the motions. Ocean, continent, convergence. So I'm looking for this. Ocean and continent moving together. So that's F. Transform boundary, that's where they slide across one another. That's C. Continent, continent, convergent. Two light plates moving together. So that's D. Hotspot. That's the one that's just lots of, like, there's only one plate. There's a big volcano, a smaller one, like that. So that's B. Ocean, ocean divergent, two dark plates moving apart. That would be E. Ocean, ocean convergent, two dark plates moving together. That would be G. And continent, continent divergent, two light plates moving apart. That's A. Now, for the where in the world does this happen? The Mid-Atlantic Ridge is between North America and Europe, and it's where the ocean is splitting apart. It's ocean-ocean divergent, so that's E. San Andreas Fault in California, part of California is moving like this, and part of California is moving like that. It's the transform boundary, that's C. East Africa, Africa's splitting apart, and it's a continent, so it's going to be like A. It's continent, continent divergent. Andes Mountains, South America, they're created by an ocean plate diving under South America. So that's like F, continent, ocean, convergent. The Himalayas, there are no volcanoes there. That's just two continents smashing into one another, converging, so that's like D. Japan is formed by two ocean plates, one ocean plate going underneath the other one. That's ocean-ocean convergent. And finally, Hawaii is the hot spot, so B. Those are all the right answers. So tomorrow, I'm going to have something just like this, except it's going to have all these kinds of features, but it'll be a different map. You'll have one thing on the map that's going to have two white-colored white plates that are going apart, but it won't be in this position. It won't be letter A necessarily. So every one of these features will be on there, just kind of like this, but it'll be a new map. And I may scramble the order of these too. I don't know, just scrambling those is probably enough. Okay, so people at home,